Hey all, Jeff here, and today I'm going to walk you through a test run of this Adaptive Pressure Advance Auto-Calibration macro I created for the Snapmaker U1. This macro uses the U1's built-in induction coil and flow calibration Klipper extension to automate pressure advance test runs and generate pressure advance values across a number of different flow and acceleration scenarios. You can use this data to configure the Adaptive Pressure Advance feature in OrcaSlicer. The reason I built this macro was to really reduce the time that it took to perform the 12 or so manual pressure advance calibration prints that you needed to do in order to calibrate and develop configuration to calibrate the Adaptive Pressure Advance feature in OrcaSlicer. It took way too long, and there was just a lot of guessing. I really sucked at being able to identify the correct PA value using those built-in calibration prints. So this macro will run a suite of tests across a number of different flow and acceleration parameters and generate a full calibration run in about 25 minutes. And it uses about 20 grams of filament. This macro has a ton of configuration options and background details on the testing methodology is documented in the GitHub repo and a blog post I created. So I'll add those links in the description of this video. Be sure to check those out for additional detail. So for this demo, I'm going to step through the first test in real time. Like I said, it's going to take 5 tests. Each test takes about 5 minutes to run. We'll walk through the first one in real time, and then I'll cut and then come back to the video and show how we generate the configuration values at the end to paste them into OrcaSlicer. So let's see, we'll switch over here. I have the macro ready to run. So I'm going to run this test suite on my second tool head, which is loaded with Snapmaker white snap speed PLA. I haven't done calibration on this yet. So what you have to do is run this APA coil run all, specify the extruder, and specify the print temperatures. And then what it'll do is select the tool head and start running the tests. So it's going should be homing. And my video is stalled. So let's see if I can go over here and get this thing to come up. There we go. So it's going to home. It's going to go and select the correct tool head. It's going to heat and then start to run a battery of tests. If you visit the GitHub page, you'll see a little bit more detail, but basically what it does is runs about 14 iterations of speed tests where it'll extrude at a certain rate and then at a certain velocity. And then once it's done with those iterations, it'll output some pressure advance values, which you'll use to interpret at the end and pass them into a secondary macro that will actually go and generate the ideal pressure advance value for that particular run. So let's see, I can go back to the console. So now we can see that it's actually running this first test. It's difficult to see on the video, but it is actually extruding. It ran the first test at using this pressure advance value here of K0.005. And then it's going to increment in 0.005 increments. So the next one will be K value of 0.010, 15, 20, 25, 30, 35. And then it'll be done with that round. And then it'll go on to the next. And what you're watching for here is for this area value to go from a positive to negative number. This is the bracket that you'll use later to run this APA finish last macro, and you'll paste in those K values. So the K and area values. So we'll see it in a minute when it switches over to when it completes the 0.20 test. So later, when this test is finished, we'll go back and run this macro. It will, the K0 value in this instance would be 0.015 with an area of 55. The K1 value will be 0.20 with the area 1 value of minus 9227. The max area value will be, you'll see when the test complete, there'll be a large number. It'll be, maybe it'll be 18,366. It may be a negative number, and then we'll use that one for that final value. And then once we paste that in, the macro will do a calculation and spit out the line number, the configuration for that you'll paste into the Adaptive Pressure Advance config in OrcaSlicer. Waiting on just one more test run, and then we'll just fast forward through the rest of them. So that test run completed. Again, we're looking for this area here where it goes from positive to negative. Oh, it's the 55 to minus 19,227 or minus 9,227. And then for the max value, it looks like we'll end up using this 35,612 value. For the max area, it doesn't really matter if it's positive or negative. You'll just add, if it is a negative value, then you just take the negative part off and put that value in for the max area. Okay, so it's starting the next test. It's running a high flow, low acceleration test. The first one was a low flow, low acceleration test. It's going to run through 3-4 more scenarios, and then we'll be back to finish up the configuration run, and I'll show you how to generate those values and how to configure OrcaSlicer for using those values. So I'll be right back. All right, so that last test has completed. So what I typically do is open up like a scratch pad or notepad on the side and go and copy and paste these values, the macro commands in, so it makes it a little easier to run. For whatever reason, the select capability in this console is a little weird. So anyway, we go back up, find our last test run, our first test run, which we ran here, and we look for this APA finish cell. So copy this command out, and then we're looking for the brackets where it goes from positive to negative. So in this instance, the K value is 15. Copy this out, and the area is 55. And for K1, it's 20. And area is negative 9,000. 227. Make sure I got that right. And then the max area is this 35,612. A little counterintuitive. So I'm going to go through and do the same thing for every test. You can see the test parameters here too, which is interesting to learn a little bit more about the methodology. Here's the second test. All right, so now we just run these final finish cell commands. Let's see, just want to make sure I have these right. Great. And then it outputs this line that you use for OrcaSlicer. So here's the first value. I'll just keep track of these in my scratch pad. And paste the second in. All right, so now that we have the values set, we can go over to our configuration in OrcaSlicer. We can edit the filament profile. We have to enable Adaptive Pressure Advance, and then we just paste these in. For the static kind of pressure advance value, typically just take the median of these. So it ranges from 10 to 17. So I'd pick 15. And then if you wanted to try Adaptive Pressure Advance for bridges or overhangs, you can enable that as well. And I typically do half of the static. So I'll put in 0.8 as a starting point. And that's it. You would save this. You need to save this as a custom filament profile to persist it. But yep, that is the extent of it. Way better than having to print out multiple test prints and try to have to guess which one looks the best. About 25 minutes of work for the printer and the sensor. It does take a good amount of purge, so you should be mindful of that when you look. You can kind of see the purge bucket gets pretty full, so make sure to have an empty purge bucket when you start, and then you should be good to go. So hopefully you find this helpful. Maybe it'll encourage you to try Adaptive Pressure Advance. I know for me it was a big turnoff, having to spend hours doing those manual prints and then doing the evaluation for every single filament. There's no way I was going to do that. But now using the sensor on the U1 and this macro makes it a little bit easier. So let me know in the comments below if you're going to try it out or if you've had any success with it. Also, feedback welcome on the macro itself. Feel free to drop some suggestions or bug reports or improvements on the GitHub issues, and I'll see if I can get to them. But good luck with it, and hopefully you'll find that it helps improve the quality of your 3D prints. Thanks.